and that was stopped.
Good morning, children. Now we are going to continue the science lesson, heat. Okay, first part I have sent you already. Now this is the second part. So let us recall what we have studied in the first part. So in the first part we have studied that heat is a form of energy. Isn't it? In that we have studied about the temperature. What is temperature? Temperature is used to measure the hotness of an object or a body. There are two types of thermometers. One is clinical thermometer and another one is laboratory thermometer. So clinical thermometer is used to measure the temperature of the human body, and laboratory thermometer is used to measure the temperature of the objects. Okay. Then we have seen the precautions taken while handling the thermometer and the working of the thermometer, the parts of the thermometer. So in clinical thermometer we have seen there is a mercury, there is a bulb, and there is a scale, Celsius scale, where you have the numbers, isn't it, where you will measure the temperature. The human body temperature, the normal human body temperature is 35 degree to 42 degree Celsius. So it is measured in degrees with the Celsius scale. Then clinical laboratory thermometer is used to measure the objects where you don't have a nick in that. It is used to measure the objects, and the objects how they are measured. All the, supposing you are measuring the this thing, temperature of the ice. So what you have to do? It must be completely the vessel or wherever you are measuring, that must be full of ice. Surrounding also ice must be there, and in the center you have to keep the thermometer and measure the temperature. Okay. Then it should be always kept straight. Which one? Laboratory thermometer. But clinical thermometer, how do you keep? Like this, isn't it? It is not straight like this. What you keep? You keep under the tongue, or you keep near the knee and all, to measure the temperature. And what are the precautions to be taken while handling the thermometer? First of all, in clinical thermometer, you have to see the readings properly. As soon as you remove from your mouth, there will be mercury which will prevent the temperature, or the knick which will prevent the temperature going down. But in the laboratory thermometer, how do you measure? As soon as you keep it in the, where you are keeping, which object you are measuring, there only you can see the temperature and record it. You cannot remove it and then record the temperature. That is the difference between clinical and the laboratory thermometer. And in clinical thermometer, it should be handled very carefully. So usually, if there will be mercury, so it is poisonous. If sometimes it is broken or it enters into the mouth, it becomes toxic. So only nowadays we are using what type of thermometers? We are using the digital thermometers. So in that you will not have this glass and all, where you will have this thing to, or mercury where it leaks out, or the glass breaks and all. So we are using the digital types of thermometers. Okay. So now what are the precautions? You must use very carefully. Then it should be handled very carefully. Mercury should not leak down. All these are the precautions to be taken while handling the clinical thermometer. So now we have studied about the thermometer. Now let us study about the transfer of heat by three methods. There are three methods of transfer of heat. One is conduction, another one is convection, another one is radiation. So these are the three where the heat is transferred. Three processes: conduction, convection and radiation. So in conduction, again you have conductors and insulators. What are conductors and what are insulators? Conductors are the substances which allow the electricity, or which allows the heat to pass through them. That is called as conductors. For example, copper, aluminium, all these will allow the heat to pass through them. Then what are insulators? Insulators are the substances which do not allow the heat to pass through them. So in conduction, the heat will be transferred from hotter substance to the colder substance, or from the hotter part to the colder part. That is called as conduction, and this takes place only in the solids. Convection, here also the heat is passed from hotter object to the colder object. But here in liquid as well as gases this process takes place. So in detail we will study on the smart board. Then radiation, in radiation there is no medium of transfer of heat. It is without the medium it can transfer the heat from one place to another. Then we will study about the sea breeze and the land breeze. Okay. So now let us first continue with the transfer of heat by conduction.
Applications of conduction. In this module, you will learn about different applications of conduction.
So here can you see where all we use the conduction. So already I told you what is conduction. Transfer of heat from hot object to the colder object.
You know that conduction is the flow of heat through a solid without the actual movement of the solid. Heat energy gets transferred from a hotter region to a colder region in the solid due to vibration of its particles.
Why it moves from the hotter region to the colder region? Because of the vibration. Means movement.
Most cooking utensils that you may have seen are made of a copper base. Why? This is because copper is a good conductor of heat. Good conductors of heat, as implied, conduct heat fast. So, in utensils with a copper base, food gets cooked fast. Let us consider some more applications of conduction.
So you would have seen when you keep the vessel on this thing, stove and all, what happens? It gets heated up. But pan and all, when you make dosa and all, what happens? Even the pan, though it is made up of rubber and all, the heat is transferred. So after a little while, it becomes hot. So which is on the stove that becomes more hotter and it passes the heat. And that heat makes the other objects also heated.
A glass vessel, while being heated, is kept over a wire gauze made of metal. Why? This is because wire gauze helps to distribute heat uniformly over the entire vessel.
So now you see here how heat is transferred. Here there is a candle and here there is a flask. So here when it is heated, this gets heated up. Uniform heat is a transfer. So now as the heat is passing, so what happens? It goes out and the cold air that joins again to this thing here, to the candle. And so this process, hot air, cold air. So like this it will be going on, passing.
You must have seen an electric iron. The bottom of an electric iron is made of metal to conduct heat to clothes. However, its handle is made of plastic. This is because plastic is a heat insulator and it helps to protect our hands from getting burnt. Let us consider some more cases where insulators are used to prevent conduction.
So here these are the examples of insulators. What is insulator? Which will not allow the heat to pass through them. Iron you have seen, we iron it, isn't it? The lower part it is hot and where you hold it, that is not hot, it is covered with the rubber. So that is insulator, which will not allow the heat to pass through it.
In hot countries, when a house is constructed, a layer of mud and straw is laid over the roof in between the concrete and bricks. Mud and straw being insulators of heat reduce the amount of heat entering the house.
So you might have seen in the villages or in the slum areas and all how they construct the houses. Straw will be there, mud will be there. So this will not allow the heat to pass through. So only they don't feel so hot.
Woolen clothes keep us warm in winter. How? Woolen clothes have fine pores with air trapped in them. Both wool and air being heat insulators prevent heat loss from the body and keep us warm.
We wear what type of clothes in the winter? We wear the woolen clothes. So how do you feel? You feel warm. Why do you feel warm? As air is also a poor conductor of heat, as well as the wool, it gives us heat. So in the winter season, what happens? Wool will keep us warm. It will not allow the air to move. So it is a heat insulator. Means what? It does not allow the heat to pass through it. So only we wear woolen clothes and we feel warm during the winter.
An ice box is a double-walled box made of plastic. The space between the walls contains a thermocol lid. Both thermocol and plastic are heat insulators and do not allow the outside heat to enter the box, thus preventing ice kept inside the box from melting. Ice blocks are covered with wood sawdust. This is because sawdust is a heat insulator and prevents ice from melting for a considerable time.
So you might have seen when you remove the ice, it melts. But when you keep it with the thermocol, inside the thermocol, what happens? It is a insulator which will not allow the outside heat to enter into the ice. So the ice will not melt and the ice cubes will be kept like that only. Okay.
An oven is also double-walled. The space between the walls of an oven is filled with the poor conductors of heat, such as black wool, to prevent the loss of heat from the oven to the surroundings. Bet you enjoy learning about the different applications of conduction.
So here you have learned how the heat is transferred from the hotter region to the colder region. How it is applicable for the conduction. So in the conduction, the heat passes from the hotter object or the substance to the colder substance.
In this module you've learnt, conduction is the flow of heat through a solid without the actual movement of the solid. During conduction in a solid, heat energy gets transferred from a hotter region to a colder region due to vibration of its particles. Good conductors of heat make conduction faster. Cooking utensils are made of a copper plate so that food gets cooked fast. The tip of a soldering iron rod is made of copper to transfer the heat quickly to the material to be soldered. A glass vessel, while being heated, is kept over a fire gauze made of metal to distribute heat uniformly over the entire vessel. The bottom of an electric iron is made of metal to conduct heat to clothes.
So now here we have studied about the conduction. Now let us study about the convection. What is convection? Now are you sure what is conduction? Can you define? So conduction is the flow of heat to a solid without the actual movement of the solid. Then during conduction in a solid, heat energy gets transferred from a hotter region to a colder region due to the vibration of its particles. And already you know what are conductors and insulators. I have explained you.
In some cases, insulators are used to prevent conduction. The handle of an iron box is made of plastic that helps to protect our hands from getting burnt. In hot countries, A layer of mud and straw is laid over the roof of a house in between concrete and bricks. Woolen clothes have fine pores with air trapped in them. Both wool and air being heat insulator prevent heat loss from the body and keep us warm. An ice box is a double-walled box made of plastic that prevents ice from melting. Ice blocks are covered with wooden sawdust that prevents ice from melting for a considerable time. The space between the walls of an oven is filled with slag wool to prevent the loss of heat from the oven to the surroundings.
So these are the insulators that are used to prevent the conduction. Okay. Now next we'll study about applications of convection.
Applications of convection. Applications of convection. You know that convection is the flow of heat involving movement of particles.
So here convection also is a
Convection takes place in liquids and gases and occurs from a hot region to a cold region.
same thing. Convection also takes place from the hotter region to the colder region. But this takes place in the liquids and gases, not in the solids.
You might have noticed that an air conditioner is usually installed near the ceiling. Why? Well, to quickly cool a room. The cool air released from an air conditioner, being dense, sinks. The warm air below, being less dense, rises and is drawn into the air conditioner. This warm air is cooled inside the air conditioner. This way, air is circulated inside the room and the room becomes cool due to convection.
So the example is air cooler. So everyone might have experienced, isn't it? In your home you have the air cooler. So what happens? What the air cooler gives you? It gives you the cool air and it is more dense and the room is warm. So the warm air is less dense. So in this way what happens? The warm air goes and the cooler air comes down. So in this way, this is a continuous process. Warm air makes it cooler and cool air and more dense and this will be less dense. So this is like this, the process will be continuous. This is called as convection. What it is called? Convection.
Did you know hot air balloons use convection currents to rise into the air? The air inside the balloon is heated. The warm air, being less dense, rises and makes the balloon rise. The cool air at the top, being denser, sinks to the bottom. This repeating cycle makes a hot air balloon rise high in the air.
So another example is hot air balloon. So in that, what they will do, they will fill the warm air and the cool air will be more dense. Because of this warm air, the balloon is able to move. So here also convection is used.
In coastal areas, a breeze generally blows from the sea towards the land during the day and from the land towards the sea during the night. Sea and land breezes are actually caused due to convection. You know that water takes a longer time to heat up and cool down than land. Let us find out how sea and land breezes are formed.
So what is sea breeze and land breeze? Here also convection takes place. So land breeze and sea breeze. Sea breeze means the people where in the coastal areas and all. What happens? there will be lot of sea, so water will be there. So during the day, what happens? The water, what is the boiling point of water? It is 100 degrees Celsius. So it takes time for the water to boil, but for the land, it heats up very fast. So what happens? This cool air from the land goes into the sea, and the sea goes into this cool warm air goes to the land. So in this way, this is, now let us see how this land and sea breeze occur. How convection takes place here.
During daytime, land heats up more than water. The air over the land becomes warm and rises up, and the cooler, denser air over the sea moves towards the land to replace it. This air moving from the sea towards the land is called a sea breeze.
So what happens? The land gets warmer fast than the water. So what happens here? This warm air goes into the air, and then that cool air comes back to the land. So this is called as the sea breeze. Sea and land. This is land and this is sea. So from the land, which air? Warmer air. From the sea, cool air. So this process goes on. Warm air, cool air. So this is called as a sea breeze.
During the night, land loses heat faster than water and becomes cooler. The air above the sea is now warmer. It rises up, and the cooler air over the land blows towards the land to take its place. This sets up convection currents, forming a land breeze at night.
So this is opposite in the land breeze. What happens? During the daytime, the land gets heated up fast than the water. So the warm air goes into the sea, then the cool air to the land. So this is called as the land breeze.
Fresh air is essential for good health, and thus a room is provided with ventilators near the ceiling. The air that we breathe out, being warmer, rises up and moves out through the ventilator. The cool, fresh air from outside enters the room through the ventilator to take its place, thus setting up a convection current.
So here again, this is an example of convection. So what we do in the room when we are sitting and studying and all, what you do, that is a warm air. So this, if you have the ventilation and all, this warm air goes out and the fresh air comes in. That is the cool air. So this is again a continuous process. Warm to cool or hot to cool. So this is again the convection. These are the various examples of transfer of heat by convection.
You might have felt that table fans keep a room much cooler than ceiling fans. During summer, the air in a room becomes warm and, being less dense, rises up. A ceiling fan circulates only warm layers of air present near the ceiling. Table fans operate at a lower level and can circulate cool layers of air coming in through windows, thereby keeping a room much cooler than ceiling fans. A freezer is generally fitted near the top in a refrigerator. The air near the top in contact with the freezer gets cooled. Being denser, it descends and the warm air from the lower part rises. This sets up convection currents that gradually cool the entire space in the refrigerator.
So here there is another example of convection. Here also in the fridge, you might have seen in the freezer and all. It will be too cool, isn't it? And down, it will not be so cool. Less, it will be warm air. So here this is also again the transfer of heat hotter region to the colder region. So this is again the example for convection.
In this module you've learned, convection is the flow of heat involving movement of particles. Convection takes place in liquids and gases and occurs from a hot region to a cold region. Some applications of convection are installation of an air conditioner near the ceiling, rising of a hot air balloon, formation of sea and land breezes, ventilation in rooms, more effectiveness of table and pedestal fans than ceiling fans, installation of a freezer near the top of a refrigerator.
So now let us study about the radiation. Now we are studying about conduction, convection. So now radiations and its applications. Already I told you what is radiation. So radiation is again here also transfer of heat takes place, but there is no medium required. Without the medium, the heat is transferred from one place to another. As in conduction takes place only in solids, I said, and convection takes place in liquids and gases. In radiations, there is no medium.
Radiation and its applications. In this module, you will learn about radiation and its applications. Many people heat their homes using a fireplace. Did you ever think how a fireplace makes a room warm? Well, radiation does not require a medium. Consider an example. While taking a walk outside on a sunny day, you feel hot. Why? You feel hot because of sun's energy that reaches the earth through radiation. Heat from the sun travels millions of kilometers from space to the earth. You may know that there is no medium in space. So, radiation can transfer heat in the absence of a medium.
So radiation here, the heat of the sun is how it comes to the earth without any medium. That is called the radiation.
All objects emit and absorb heat radiations at all temperatures. The emitting and absorption power of different objects at the same temperature is different. A dull or black surface emits more heat radiation than a polished or white surface at the same temperature. Similarly, a dull or black surface is a good absorber of heat radiation than a polished or white surface. Let us now discuss some applications of black and white surfaces. The cooking utensils are painted black so that the utensils can absorb more heat and help to cook food fast.
So why the wooden
Teapots are usually made of polished ceramics. This is because a polished surface is a poor emitter of heat. Thus, shiny teapots can keep tea warm for a longer time.
Okay, now black surfaces are the good absorbers of heat. It will absorb the heat fast, black surfaces, and the polished surfaces are the poor emitters of heat.
You may have seen a vacuum flask. It has a polished silvery surface. We prefer wearing white or light-colored clothes in summer. Why? This is because white or light-colored clothes, being a poor absorber of heat, reflect heat and keep us cool.
So why do we wear light color or cotton clothes in the summer? Because it is a poor absorber of heat and it keeps our body cool. We feel cool.
You might have observed that tankers carrying flammable substances like petrol are painted white. This is because white color, being a poor absorber of heat, prevents flammable substances from catching fire. A car radiator is black so that it can radiate heat from the engine to the outside. Ever seen a greenhouse? It is made of glass and usually built in cold places. It traps solar radiation to help plants grow better. During daytime, solar radiation passes through the glass walls of a greenhouse, thereby providing heat to plants. The infrared radiation emitted from plants gets trapped inside a greenhouse. This provides warm surroundings for plants to grow. In this module you have learnt, radiation is transfer of heat in the form of rays or waves. It does not require a medium. Dull or black surfaces are good emitters and absorbers of heat radiation than polished or white surfaces at the same temperature. Some applications of black and white surfaces are: the cooking utensils are painted black, teapots and vacuum flasks are made of a shiny polished material. We wear white or light colored clothes in summer and black or dark colored clothes in winter. Cooling films at the back of a refrigerator and car radiators are painted black. Tankers carrying flammable substances like petrol are painted white. A greenhouse helps plants grow better by trapping solar radiation.
So this we have studied about radiation now.
Transfer of heat by conduction. In this module, you will learn about the...
So here there is an experiment which has to be done, that is transfer of heat by conduction. How the heat is transferred by conduction.
A few minutes on a pan that is placed on the stove. However, the flame does not touch the egg. Then how does the heat from the flame reach the egg? You will be able to answer the question after this experiment. This is an experiment that demonstrates the transfer of heat in solids. In order to perform this experiment, we require a flat metal strip, 5 small nails, wax, clamp stand, a candle, and a matchbox.
So to do these experiments, what are the items required? Flat metal stripe, you can see here, small nails, wax, clamp stand, candle and matchbox. Wax means what? After the melting of the candle you will have, no, that is called as a wax.
First of all, fix all the 5 nails to the metal strip using wax. The nails are to be equally spaced. Also, leave some space on both the ends of the metal strip. Now, fix the metal strip on the clamp stand horizontally. The nails should be hanging from the bottom side of the strip. Next, light the candle and place it under the free end of the metal strip to heat it. Observe carefully. The nail nearest to the flame falls first, then the next nail. Here's the third one, the fourth one, and now the farthest nail falls. But why do these nails fall?
Have you seen how the nails have fallen? So for what it is fallen? It is
All the nails fell down one by one because the wax that fixed them to the metal strip melted. You have also observed that the nail nearest to the flame fell first and the farthest nail fell last. the wax pieces melted off one by one. This indicates that heat reached the wax pieces at different times. First, heat reached the wax piece nearest to the flame, then to the next wax piece, and so on. That is, the heat flow occurred gradually from the hot end of the metal strip to the cold end. Note that throughout the process, the metal strip remained stationary. This type of heat transfer, which occurs without the actual movement of the medium, is called conduction. Conduction mainly takes place in solids. Now you can answer the question we had in the beginning. The pan is made of a conducting material. Heat travels from the flame to the pan and then to the egg by conduction.
Okay, so this was the experiment which has to be shown. Transfer of heat by.
In this module, you have learnt that conduction is the type of heat transfer which occurs without the actual movement of the medium. It mainly takes place in solids. In conduction, the heat flows from the hot end to the cold end. Transfer of heat by convection. You will learn about the transfer of heat by convection.
This also you have the experiment in the textbook. Previous one also you had in the textbook. Now this also you had in the textbook. Let us see through the smart board.
Water is boiled by heating it under the container. It cannot be done by heating it from the side or from the top. This is because of the peculiar way heat is transferred in liquids. Let us perform an activity to demonstrate the transfer of heat in liquids and gases. The items required for this activity are a round bottom flask, tripod stand, candle, matchbox, straw, potassium permanganate crystals, and water.
So what are the items required for this experiment? Is flask, tripod stand, candle, matchbox, straw, potassium permanganate, and water.
Fill approximately 2/3 of the flask with water and place it on the tripod stand. Wait till the water in the flask is still. Now, with the help of a straw, gently place a crystal of potassium permanganate at the bottom of the flask. Now, heat the water by placing the lighted candle just below the crystal. Heat transfer in liquids takes place by the process of convection. But what about the heat transfer in gases? Let us see. Observe the smoke coming out of a burning incense stick. The effect may not be as clear as in the case of water. This is because even a slight movement in air can disturb the smoke. If there is no movement in air, then the smoke does not spread immediately around. First, it rises up and then spreads. This is because the air near the burning tip gets hot and rises up. Cold air from the sides moves downwards and the process repeats. Here again, there is an actual transfer of the particles of the medium. That is, in the case of gases too, convection is the mode of transfer of heat. You can test this by holding your palm at a safe height above a candle flame. The palm feels hot only when it is held directly above the flame. If the palm is held on the sides of the flame, it does not feel so hot. This is because of the fact that hot air always rises up as it becomes lighter. So, it can be inferred that convection is the mode of heat transfer in both liquids and gases.
So here in this module we have seen that convection is the mode of heat of transfer in both liquid as well as in the gases.
In this module you have learnt convection is the mode of transfer of heat in liquids and gases. In convection, there is an actual transfer of the particles of the medium.
Last year you did not get these results.
Now the last part of the lesson is light colored and dark colored clothes.
Light colored and dark colored surface. In this module, you will learn the effect of color of a surface on the absorption.
You will learn about the effect of the color of a surface on the absorption and the release of heat.
Have you ever wondered what is the effect of color of a surface on the absorption and release of the heat? Let us perform a simple activity to answer this question. Items required for this activity are 4 identical tin cans with lids, 2 with the outer surfaces painted black and the other 2 with the outer surfaces painted white, water at room temperature, boiling water and thermometer.
So the items required are identical twin tins, water, boiling water and the thermometer.
To begin the activity, take 2 cans, one black and the other white, and pour equal amounts of boiling water into them. Close the cans and keep them in shade for 15 to 20 minutes. Now take the water which is at the room temperature and measure its temperature. It is 26 degrees Celsius. Now keep them in the midday sun for 1 hour. After an hour, check the temperature of water in all the 4 cans. Let us begin with the 2 cans in which we had kept boiling water. Temperature of water in the white can is 59 degrees Celsius and temperature of water in the black can is 54 degrees Celsius. Thus, the temperature is less for water kept in the black can. This means that the black surface releases heat at a faster rate. In general, black or dark colored surfaces release heat at a faster rate than white or light colored surfaces. After that, check the temperature of water in both the cans placed in the sunlight. It may have risen by now. Let us check. First, measure the temperature of water in the white can. It is 32 degrees Celsius. What about the temperature of water in the black can? It is 37 degrees Celsius. The temperature of water in the black can is higher. We have taken the same amount of water at the same temperature in 2 identical cans and kept them in the same conditions for the same amount of time. Yet, the temperature of water is higher in the black can. Why? This is because of the difference in the amount of heat absorbed by the 2 cans. The black surface absorbed more heat in 1 hour than the white surface. In general, black or dark colored surfaces absorb heat at a faster rate than white or light colored surfaces. In this module you've learnt black or dark colored surfaces absorb and release heat at a faster rate than white or light colored surfaces.
Okay children, now I have shown the experiments, I have explained to you about the transfer of heat by three ways: conduction, convection and radiation. So see the experiments, and if you are able to do, try to do it at home and you can write your observations. Okay, so here we have completed the chapter heat. You will be getting the PDF notes, you can complete the notes and be prepared for the FA1 test. Thank you.
Madam.